Hello everyone, this is Aruna. I am your facilitator for the software testing fundamentals and quality center training sessions. I have around 10 years experience in software testing in top consulting MNCs, and I hope I will be able to give you some insight on software testing and quality center ALM 11 tool, which is very widely used for test case creation and test case execution, as well as requirements and defect management. Don't worry, I will be covering all this in all my training material over the next couple of training sessions. Let me go over the contents of this training session. I will be covering why testing is necessary along with testing techniques, how we do test planning and execution and defect management, and last but not the least, HP Quality Center ALM 11. What is testing? Testing is a process where we try to identify the correctness and completeness of and quality of the computer software. So basically, you're deciding if the software is as per the requirements given by the customer and whether it is reliable. Apart from finding errors, we also need to test applications for safety, security and performance. For example, you have a banking application where anybody can hack into your bank accounts due to lack of safety. I am sure as a customer we won't be happy, neither will the bank. So obviously safety and security is very important in today's world. So that's why we have to test performance, safety, also find defects and security as well. There are two main concepts in testing, which is software testing and software quality assurance. We need to understand the difference between these two concepts. What is quality assurance? Quality assurance means we are reviewing and auditing software products to ensure compliance with current standards and procedures. And what is testing? Testing is a process where we try to uncover errors before the product is delivered to the customer, and also to create confidence that the product is working well. So that means testing is where you're finding defects in the application and ensuring reliability. Quality assurance is you are trying to verify that you're complying with the applicable procedures and standards. Since we're talking about defects, there are three main concepts which we have to understand. One is error, the second is fault, the third is failure. What is an error? A human action which produces an incorrect result is an error, and the result of that error in software means a fault, which is also known as a defect or a bug. And a deviation of the software from the way it's expected to perform is failure. So let's go through that again: error, fault and failure. Okay, so if you look at error, a person makes an error which then gets converted to a fault in the software, then it leads to a failure in the operation of the software, thereby that's a failure, right? Now, since we are talking of software failures, the first question which anyone will come up with is, why can't we eliminate all software failures? There are many reasons for this. It's finally us who are creating code for the software applications. So obviously these applications are complex and we are hardly free of faults. So there are enough faults added into software applications. Most of the applications today are highly complex. So let's look at a simple web application for checking emails. Even that application has to be HTTPS, which is secured User has to be having login and password. You have to show him only his emails. Spam should not come. Mails should be delivered very quickly. So we have a huge set of complex requirements. So that's the second reason why failures can't be eliminated. Apart from this, we have a limited time to test an application and figure out defects in it. We don't have unlimited time and resources for that, and thereby we cannot test all possible input combinations. And sometimes it's more competitive to release an application early into the market to get the benefit of a new product being launched, or to get the benefit of getting more customers in, or of an early release. So there are competitive advantages of releasing earlier. So obviously, in the limitation of time, we do have software failures which don't get picked up. Since we're talking of failure, the next logical thing which we should talk about is reliability. So far we have said that every software does have faults or defects, because humans are developing and coding the software. So we are questioning reliability. What is reliability? It is the probability that the software will not cause failure in the software system. Now there are three questions here. I think if we analyze them, we will know the answers to them very clearly. Can a system be fault free? Obviously, since systems are complex and it's not possible to analyze and figure out all combinations of inputs, they cannot be fault free, and humans are coding them, so there are errors. So it cannot be fault free, that is delivered right for the first time. But can you still have a software which we will call reliable, and it will still have some defects in it? Yes, because that's how most applications are delivered. And then, for example, you have Windows, which gets launched with Windows 8, and then it keeps releasing new service packs to keep fixing ongoing builds and defects. So can a software system be reliable and still have faults? Yes. Now the third question is a fault free software application always reliable? Is it possible to have a fault free software application? No. So obviously this answer is no. I hope everyone has understood what reliability means and whether you can have a fault free application or not. Now coming to testing, there is a fundamental limitation for testing. By now I'm sure you must have all guessed it. The limitation is that you don't have unlimited resources and time available with you. So you have to decide how much to test and when to stop your testing, when to decide that we have figured out all major defects and they have been fixed, and we will go ahead with the existing defects in the software. So that is called an exit criteria, which we will be covering in future training sessions in test planning and test case creation, etc. So testing can only show presence of an error, and it cannot prove that there is no error at all. Just to reiterate what was discussed earlier, why do faults occur? One is because it's written by human beings. The second is you have very strict deadlines to deliver, and because of that you have to push the release through. And if you have ever done coding, you will know that writing programs is very complex, and nowadays applications are very complex, so there will be some errors in software. So since we were discussing why testing is necessary so far, these are all the statements, and I'm sure you can get an answer to it if you think about it. Why is testing necessary? Because software is likely to have faults. Yes. To learn about reliability of the software, I'm sure obviously by now you know that. To fill the time between delivery of the software and release date, obviously that's That's not the purpose of testing, so that's not right. Even the next point, which is software has no faults, it's not possible to have a fault-free software application. Are we doing testing just because it's included in the project plan, because the client is giving us a budget for that? We are doing it to ensure reliability of the application. So obviously this is not right. Now, failures can be expensive. This statement means that if you have a banking application, for example, and you find a defect in funds transfer at the time when it's already released to millions of customers, fixing it at that point of time means downtime of the application, rolling back the issues you created because of incorrect funds transfer, which means a lot of money spent by the bank. I'm sure the bank won't be happy. So failures should be fixed in the initial phases, which is true. Failures can be expensive to avoid being sued by customers, which is also true. And to stay in business, obviously we are all here for the competitiveness in the market. So since we are saying failures can be expensive to fix, why not test everything? Test everything? Is that possible? Let's look at one example. We have a system which is having, say, 20 screens, like for example a banking application or airline ticketing system. Each screen has an average of 4 menus. Each menu has about 3 options per menu, okay, and each page has 10 fields per screen. Every input field has 2 types of inputs, say just like date or integer or decimal. So we're talking of about 100 combinations here. So if you want to test everything, we will have to test 20 screens multiplied by 4 menus and 3 options per menu, 10 fields per screen, 2 types of input and 100 combinations, which means 480,000 tests, which converts to about 17.7 days if you say 1 second per test. This is not including the faults which we find or the retesting required. Obviously we don't have such huge amount of time to keep testing, so it's not possible to test everything. What is exhaustive testing? We decide all combinations which we are planning to test, and we test them. So exercising all combinations of inputs and preconditions. And will we always execute all planned tests? No. Sometimes we will decide to stop testing based on the needs of the release. So, and exhaustive testing, as we saw in the previous example, will take infinite time. So it's not possible. It takes an impractical amount of time. Thereby we don't want to do exhaustive testing. Now I'm sure you can answer whether these statements are right or wrong. How much testing is enough? Testing is never enough. Okay, so you say testing is enough when we have proved that the system works correctly and you're confident that it's working fine, also based on the risks of your system, right? So only the last 2 points are right and the rest of them are not right at all. What do we mean by risk? Now, risk is the risk of missing important faults, thereby the cost of them, cost of fixing these important faults, risk of releasing untested or undertested software. So you will have a software with a lot of bugs, which obviously customers won't be happy. If the customers are not happy, you will lose credibility and the market share. And if your application is not up to the mark, you will lose a market window wherein some other competitor will go ahead and take market share. And you can't test all possible combinations, or you're just going over the board, so you'll never have an application ready. So that's the important point to understand about risk. So you decide based on risk how many tests to execute.